Okay, imagine this. You could take a field trip to the surface of Mars, or shrink down to explore the inside of a human cell, or maybe even walk through ancient Rome while it was still being built. I mean, this is the incredible promise of virtual reality in education, right? It makes the impossible possible. The hype is absolutely massive. But does it actually work? And that's really the billion-dollar question, isn't it? Is just putting a headset on a student a guaranteed ticket to better learning? Well, as with most things in life, the answer is a little more complicated than a simple yes or no. You see, the tech is one thing, but how we actually use it? Well, that's everything. Because, it turns out the real magic of a VR learning experience doesn't just come from some fancy 3D model you're looking at. Nope. It all hinges on something way more fundamental: how you are allowed to interact with that model. And if you get that part wrong, all of that amazing potential can just fall flat. To really get this, let's break down the two basic ways we can explore a 3D object in a virtual space. First, you've got what's called object movement. Just picture being in a museum and you're rotating a small fossil on a pedestal right in front of you. You're moving the object. Simple enough. The second way is viewer movement. Now, imagine that fossil is a giant, full-size T-Rex skeleton. You can't exactly spin that around, can you? So instead, you walk around it to see it from all the different angles. Two very simple ideas, but as we'll see, they have profoundly different effects on our brains. So to figure out which of these methods actually works best for learning, researchers designed this really brilliant experiment. They had people learn to identify 4 different, pretty complex fish swimming patterns by studying these dynamic 3D models. And it's actually the perfect test, because to understand these movements, you have to be able to see them from multiple perspectives. So the researchers split this whole thing into 2 big parts. First up was a low immersion test, basically on a standard computer screen. They call it desktop VR, where you did everything with a mouse. Then for the second part, they went all in with a high immersion test, using a full VR headset and controllers, where you are truly inside that virtual world. But here's the wild card. The secret ingredient that changes everything is a learner's individual visuospatial ability. It's basically your natural skill for mentally rotating objects in your mind's eye. You know the type. Some people are just natural mental rotators. They can flip and spin shapes in their head, no problem. And then there's the rest of us who kind of have to physically turn the map around to figure out which way is north. Well, this one cognitive difference turned out to be the absolute key to the whole thing. Okay, so we've got 2 ways to interact, 2 different VR environments, and 2 different types of learners. So which combination is the winning formula? The answer is fascinating and probably not what you'd expect. Let's look at the desktop VR results first, because this is where it starts to get weird. On a normal computer screen, when things got difficult, learners with high visuospatial ability, those natural mental rotators, they learned best when they could move the camera around the fish, that viewer movement method. But, and this is a big but, for learners with lower ability, that exact same method actually made it harder for them to learn. But here's where it gets really nuts. You take those same people and you put them into a fully immersive VR headset, and the results completely flip on their head. All of a sudden, those same high-ability learners did much, much better when they could rotate the object itself, like holding the fish right in their hands. Meanwhile, the learners with lower ability, they tended to get a bigger boost from physically walking around the object. And this just brilliantly illustrates the core twist of this entire study. The best way to interact with a 3D model completely changes depending on the technology you're using. You can't just take an app that works on a computer screen, port it over to a headset, and expect the same results. It just doesn't work that way. The rules for learning are literally different in these 2 worlds. And hey, don't just take my word for it. The researchers themselves state it perfectly. The strategies you'd use to design a learning experience in one medium, they just don't copy and paste into another. And that has some huge implications for anyone out there building educational software. So what's the big takeaway here? What does this all boil down to? It's this. The idea of a single best way to learn in VR, it's a myth. The ultimate classroom isn't just about giving everyone a headset. It's about creating tools that are smart enough to adapt, not just to the technology,
but to the unique cognitive abilities of every single learner. One size truly fits none.
And that leaves us with a really big and, frankly, exciting challenge. It's not just about building virtual worlds anymore, it's about building intelligent ones. So, the question we all need to be asking now is, how do we design these new tools not just to teach, but to actually understand the student and adapt in real time? Because the answer to that, well, that could truly change everything.